So let's start from here. It's just evaluate this integral. Now this f chosen to be the c to the power n. Okay, and dz. I'm going through a loop, right? And this loop, we and this n can be a n is integer, n is integer. So n equals to 0 plus or minus 1. N is integer, right? And we already checked that for all the positive n, obviously n is 0 is just a constant, right? It's just 1. And for all the positive n, this is analytic. For negative n, this is not analytic. You can check that because for negative n, obviously as z equals 0 is blow up, this function f will be singular at 0. So now, so the path that we'll choose is to going through this possible singularity. So this is 0, and you can choose a certain path. I think your textbook choose a circle. I mean, it doesn't matter. Later on, we'll talk about the quadratic theorem. You know that it doesn't matter. So going through a radius of, say, whatever that radius you can call it. So radius is R. Okay, capital R. And, okay, and then we'll evaluate that in a straightforward manner. So, so in this case, this path C is just a circle, and there's an obvious way to evaluate this integral using a parameter, using the parameter that is the angle of this, whatever at a certain z, this is the polar angle, and we can choose this polar angle as a parameter in the integration. So the z is obviously at the location is just capital R, the radius. Okay. And when we go through the circle, obviously our radius is the same, unchanged. The dr, dz from here is just d theta because r is a constant along the circle. Just do the usual derivatives, we get y r right? Because exponential function, the derivative is exponential function, and then d theta, right? So that's this is just the derivative of dz d theta. So you multiply dz equals to the derivative times the d theta. Okay, and so that is dz, and z and c to the power n is obviously this r to the n e to the n. Right. So you substitute everything, substitute this and that into here. So now this is r to the n e to the I n theta is c to the power n, and dz is I r e n theta. Okay, and the loop is obviously you can start any point, just going around in 2 pi with the whole circle. So you can like start theta from 0 and going to 2 pi. 0 is here, going around to 2 pi, going back to here, just like here. So A and B are the same point now. Okay. And this integral is obvious. You know how to do this integral. So first you take out all the constant. You have I, you have r to the power n plus 1, and then integrate e to the I. You have I n theta times I theta, which is I n plus 1 theta. Okay. Okay. Can you all follow? Uh, you know how to do this integral, right? Everyone know how?
It will give e power in plus 1 theta divided by in.
Divided by this arc. Okay, yeah, sure. Yeah. Plus 1 e to the I n plus 1 theta divided by I n plus 1. Okay. And evaluate at I n point, right? 0 to 2 pi. Now, what is this? So you know, right, that is given by that, but what is this? The office, can you see that right away? What is the value of this one? So evaluate at the endpoint, the two endpoint that this is evaluated at the 2 pi, and then minus evaluate this at 0. Obviously, this is just a constant.
1 minus.
First, does it depend on n? What the value of it does it depend on n? What about the n equals 0? If n is 0, this is just 1. 0, this is ei theta. Evaluate e to the 2 pi minus e to the 0. What is e to the 2 pi? I 2 pi. That is 0, right? How about n equals 1, 2, also 0. But yeah, so there will be 0 for some n. But is there a case that it's not 0? When n is negative, and what is n?
Oh, 0, so it will be 1.
Right, is 1.
Minus.
Can we actually do that with n equal 1 is just 0. I'm asking n equal minus 1. What is that? That yeah, n is minus 1 is this is 0. It's divided by 0. Not possible. You actually tricked by your answer, your previous answer divided by that. But n is minus 1, you don't use this formula, right? So your answer was right, but that is assuming n plus 1 is not 0. If n is minus 1, then you cannot use this formula. Actually, I should use this should be here. For all other n, for n not equals to minus 1. And obviously, you already answered. N is not minus 1, you can use this formula. And the denominator is non-zero. And e to the 2 pi times any integer times I e to that is always 1. And e to the 0 is 1. 1 minus 1 is 0. It's always 0. Okay? But for n is minus 1, you cannot use that. And what should this integral be? N is minus 1. What is this exponential? N is minus 1. E to the I. N plus 1 is 0.
So
1. This is 1, right? And you integrate from 0 to 2 pi. What is that? 2 pi. Yeah, 2 pi. 2 pi times I times R to the n minus n plus 1. N plus 1 is still 0. So this is 1. So that's everything is 2 pi. Okay. And it gives the minus 1. Okay. So that is, I spent a lot of time here because this is, you need to remember this. Okay. This is central to our the later application.